We are going to start now lecture 3 of chapter 13 class 9th mathematics. It is surface areas and volumes. So in the first lecture we have discussed about the surface area and volume related to cubes and cuboids. Then in the second lecture we have discussed the surface area related to cylinder. Now in this lecture we will talk about the surface area and volumes related to cones. So first we have the definition of right circular cone. So we are saying the solid generated by rotating a right angled triangle about one of its sides containing the right angle is called a right circular cone. So we see several examples of cone in our daily life. It is, we can say, ice cream cones are there, then some conical vessels are there, then clown's cap is there, or you can say the birthday caps that we see. These all shapes, these are of the form of right circular cone. So what this definition over here, this right circular cone, this definition is saying is that is, suppose we have a right angled triangle and we rotate this right angled triangle about this line we have fixed over here, and we are rotating this right angled triangle about this line. So what we get is, we get some figure like this. We are saying it is rotating like this. We have rotated this right angled triangle, and then this figure we obtain over here, this kind of figure, it is a cone. So right angle, because this angle over here, it is right angle, that is why it is called right angled cone. Next we are talking about, if this is the cone that we have, this is the cone we are talking about, this is the cone we are talking about, then this A is called the vertex of the cone. This point A over here, this is called the vertex of the cone. Its base is a circle with center at O. We are talking about the base, this circle over here. We are saying this is the base, and center of this circle it is O, and radius is OB. The length OA, we are talking about this length OA, is the height of the cone, and length AB, this length we are talking about, this length AB is called the slant height. So height of the cone we are writing it is H, and slant height means this AB we are talking about, this is called the slant height. So this angle we have over here, it is 90 degrees. So we have is, if you look at this right angled triangle, so the relation between these three, we are talking about H, L and R, the relation between these three is R square plus H square is equal to L square. So we get slant height is equal to square root of R square plus H square. So in this chapter we are restricted to right circular cone. Right circular cone means in place of right angle there may be some other angles, and there are some other type of cones also, but we are particularly restricted to right circular cones, in which slant height we can calculate using the Pythagoras theorem, that is L is equal to square root of R square plus H square. So next we are given some formulas related to the cone. So first we are talking about, if the radius of the cone it is R, then we are saying the height of the cone it is H, and the slight height of the cone it is L. If we have these three values over here, then we are saying that the relation between R, H and L we have already seen, that L is equal to square root of H square plus R square. Now if suppose I am talking about a cylinder, we have a cylinder over here whose radius is R and whose height is H, and we are talking about a cone whose radius is R and height is H. So if we fill this cone with, say, water, and we transfer this to this cylinder, what we see is that we require 3 cones to fill this cylinder. So what this thing will show us, that if the volume of the cylinder, if the volume of this cylinder we know it is pi r square h, and we are saying that 3 cones will fill this cylinder, it means the volume of this cone will be 1 by 3 pi r square h. So to remember the formula, I am telling you this thing, that to fill a cylinder we require 3 cones, or you can say that we can fit 3 cones in this cylinder. In this cylinder we can fit these 3 cones. So the volume of the cylinder, the formula for the volume of the cylinder, it is 1 by 3 pi r square h. Pi r square h is the volume of the cylinder, and 3 cylinders and 3 cones are required to fill it. So it is 1 by 3 pi r square h. Next is the area of the curved surface we are talking about. So now next thing we have to calculate is the area of the curved surface. So if we are saying, suppose we are having a cone over here, and this radius it is r, this height it is h, and this is the slant height l. If we cut this cone, then what we will have is, we cut this cone like this. I'm marking it with this red line. We cut this cone, so what we will get is, we will get some area like this. We are saying, when we were talking about the cylinder, we have cut the cylinder like this, and what we have obtained is, we have obtained a rectangle. But now when we are cutting this cone, we are getting some sector. We are saying this is the sector we are obtaining, and the length over here, this is L. This length we are talking about, it is L, and the area of this sector we are talking about, that will be pi r into L. So the formula of the curved surface area of the cone, it is pi r L, or in place of L we can write it is pi r square root of h square plus r square units. Now the total surface area we have to calculate. Total surface area means that this circle is to be included, and we know that the area of this circle is pi r square. The curved surface area we are saying it is pi r L. So sum of both these, it is pi r L plus pi r square. So it is equal to pi r into L plus r square units. So this is the total surface area of this cone. This is the curved surface area, this is the total surface area, and 1 by 3 pi r square h is the volume, and this is the slant height. Now the question we have is, the height of a cone is 24 centimeter. So height means we are talking about this length over here, it is 24 centimeter, and diameter of the base is 14. So diameter is 14 means the radius is 7 centimeter. Find the slant height, volume, area of curved surface, and the total surface area of the cone. So we are just using directly the formulas over here. So for slant height we know L is equal to square root of h square plus r square. Now what is h over here? It is 24 square. R over here it is 7 square. So it is 24 square plus 7 square, and when you will solve this value, you will get that the answer is 25. So 25 is the slant height. Now next we have volume of the cone. So volume of the cone, the formula we have, it is 1 by 3 pi r square h. So it is 1 by 3, pi is 22 by 7, r square we are talking about, the radius of the cone, it is 7. So it is 7 into 7, and height over here it is 24. So what we get is, this 7 gets cancelled and this gets cancelled. So when you multiply these values, you will get the answer is 1232 centimeter cube. Next we have to find the curved surface area of the cone. The formula we know, it is pi r L. Again it is 22 by 7 into radius is 7 and L is 25. The answer you will get, it is 550 centimeter square. Now the last thing we have to calculate is the total surface area. For total surface area, we have to add the area of this circle, it is pi r square. So it is 22 by 7 into 7 into 7, these two gets cancelled, and this is the area of this circle, and this is the area of the lateral surface area. So when we add these two values, we will get the answer is 704 centimeter square. Next is how many meters of cloth 5 meter wide is required to make. We are talking about a cloth is there and the width of the cloth it is 5 meter wide is required to make a conical tent whose base radius is 7 meter and whose height is 24 meters. So suppose we are saying the area, the length of the cloth required, it is x. So area of this cloth will be 5x. We want to make the tent over here. So for tent means we are talking about we require the cloth for this boundary only. We do not require the cloth at the base. Not required for the base. So what we want to find is we want to find the lateral surface area of this cone. So for lateral surface area we need the slant height because the formula is pi r l. So slant height will be square root of 24 square plus 7 square and the answer will be 25. So the area of the curved surface area we will get it is 22 by 7 into 7 into 25 and the answer we will get it is 550 centimeter square. And this area should be equal to 5 times x. So the value of x we will get it is 550 by 5 meter, that is equal to 110 meters. So this value we will get it is equal to 110 meters. Next we are given that the height and slant height of the cone are, this is the height and this is the slant height of the cone. These are the values given to us. It is 21 and 28. We have to find the volume of the cone. For the volume of the cone we know that the formula is 1 by 3. The volume of the cylinder it is 1 by 3 pi r square h. Now it means we want to find the value of this radius over here. We want to find the value of this radius r. So what we have is 21 square plus r square is equal to 28 square. So this gives us r is equal to square root of 28 square minus 21 square. So it is a square minus b square. So we get it is square root of 28 plus 21 into 28 minus 21. So 28 plus 21 means we are talking about it is 49 and this value it is 7. So value of r we will get is equal to square root of 49 into 7. So it is equal to 7 root 7 centimeters. Now the volume of the cone will be 1 by 3 pi r square h. So what we get is it is 1 by 3 pi is 22 by 7. R square we are talking about it is 7 root 7 and it is whole square over here. And the value of h we have it is 21. So when we square this term we get it is 49 into 7. Then the 7 gets cancelled over here. This 3 7s are 21. So what we are left with is 22 into 7 cube. So it is 343 and the final answer that we will obtain it is 7546 centimeter. This is the final answer that we will have, that is the volume of the cone. Next that is given to us is the volume of the right circular cone is 9856 centimeter cube. If the diameter of the base is 28 centimeter, so diameter is 28 means the radius is equal to 14 centimeter. Volume is given to be 9856 and we know that the volume of the cone is 1 by 3 pi r square h. So 9856 is equal to 1 by 3 pi r square means 14 into 14 into h. So the value of h we will get it is 9856 into 3 into this is 22 by 7. So we get 7 over 22 into 14 into 40. So when we will solve this value, we will get it is equal to 48. So 48 centimeter is the height, and this is the first thing that we have to calculate, what is the height of the cone. So we have the value of R is 14, value of H is 48. Next thing we have to calculate is the slant height. So slant height will be 14 square plus 48 square and whole square root. So the answer we will get it is square root of 2500, that is equal to 50. So we are saying the slant height of this cone, it is 50 centimeters. Next thing we have to calculate is the curved surface area of the cone, and the formula for the curved surface area we have it is pi r L. Now pi means we are talking about it is 22 by 7. The value of r it is 14, and the value of L we have it is 50. And when we will solve this value, you will get the answer is 2200 centimeter square. So this is the curved surface area of the cone. Now the next thing we have is the radius and height of a right circular cone are in the ratio of 5:12. So it means for some constant x, we have the radius is 5x and the height is 12x. Next it is given that then its volume is 2512 cubic centimeters. The formula for the volume of the cone we have it is 1 by 3 the volume of the cylinder, that is pi r square h, and its value is 2512 centimeter cube. All these values, these are in centimeter we are saying, so it is 1 by 3 pi r square means we are talking about it is 5x square, and height it is 12x is equal to 2512. So this gives us that 1 by 3 into 22 by 7 into 25 into 12 x cube is equal to 2512. When you will solve this value, you will get x cube is equal to 8, and this will give us x is equal to 2. So what we get is that the radius, that is equal to 5x, it is 10 centimeter, and the height, that is equal to 12x, that is equal to 24 centimeters. Now we have the value of radius and height, and we know the formula for the slant height is square root of r square plus h square. Value of radius is 10, so it is 10 square, height is 24 plus 24 square and whole square root. This whole value it is square root over here. So when you will solve this, you will get that it is the total value it is square root of 676, and square root of 676 is 26 centimeters. So you can see that 676 we are talking about square root. So one method is that you can directly calculate the square root over here, that it is 2 to the 4. We are left with 276. Now it is 4 over here, and 46 into 6 is 276. We are left with remainder 0. So the answer we are getting it is 26 centimeter. Now the main thing that we have to find over here is find the curved and the total surface area of the cone, and we have to use the value of pi is 3.14. So over here also we should use the value, we should not use this value, we should use value 3.14 over here. So we will get this answer. So now the curved surface area, the formula for the curved surface area is pi r L. The value of pi it is 3.14, r it is 10, and L we have calculated it is 26. So when you multiply these values, you will get the answer is 816.4 centimeter square. Next thing we have to calculate is the total surface area. So we have to add the base area to it. Base area means we are talking about that the cone is there. This is the literal surface area, and this area, this is the base area. The radius over here it is r, that is equal to, we have calculated is 10 centimeters. So area of this circlet is pi r square, so it is 3.14 into 10 square. So the answer you will get it is 314. So the total area is the curved surface area plus the area of the base region. So the answer you will get it is 1130.4 centimeter square. Next, it is given that a cone of height 8 meter has a curved surface area 188.4 square meters. So height of the cone is given to us. It is 8 meter. Curved surface area means this is the value of pi RL, that is equal to pi r square root of r square plus h square, that is given to be 188.4 square meters. So we have to find the volume. So from this equation we are saying if we substitute the value of h, we get it is 3.14. we have to use pi is equal to 3.14. Whatever is given to us, we have to use that value into r we want to calculate. It is square root of r square plus h square is 64 is equal to 188.4. So we divide this term on this side, we get r square root of r square plus 64 is equal to 188.4 over 313.14. The answer we will get it is 60. So now if we square both sides, we get it is r square into r square plus 64 is equal to 60 square, that is equal to 3600. Now this will become r raised to the power 4 plus 64 r square, that is equal to 3600. So it is r raised to the power 4 plus 64 r square minus 3600 is equal to 0. So what we can do to solve this is we can replace this r square with some t. We are talking about this r square, we are replacing with t, so this will become t square. So we have t square plus 64t minus 3600 is equal to 0. So how we can factorize it? It is t square plus, we are saying 100t minus 36t minus 3600 is equal to 0. From these two terms we can take t common, so it is t plus 100. We can take minus 36 common, so it is t plus 100 is equal to 0. So we get two values of t, one is minus 100 and one is 36. So what we have substituted? We have substituted t is equal to r square is equal to minus 100 or 36. So we are saying this minus 100 is not possible. So r square is equal to 36 and this implies r is equal to 6 units. So what we have obtained is that the radius of the base is 6 meters. Now if the radius is 6 meters and the height that is given to us, it is 8 meters. So using the formula 1 by 3 pi r square h, we can calculate the volume of the cone. So it is 1 by 3, value of pi is 3.14 into r square means 6 into 6 into 8. So when you will solve this value, you will get the final answer is 301.44 meter cube. Next is what length of tarpaulin 3 meter wide is required. We are talking about the width is 3 meter to make a conical tent of height. Conical tent we have to make and its height is 8 meters and the radius is 6 meters. We have to assume that the extra length of material required for stitching margins and wastage in cutting is 20 centimeter. So what we know now is that the lateral surface area of both these figures should be for this cone should be equal to the area of this region, whatever the length we have. Suppose the length we have it is x. So first thing we have to calculate is the slant height over here. So slant height will be 8 square plus 6 square root, and this value comes out to be 10 meters. So slant height we have it is 10 meter. So the curved surface area will be pi r l, that is it is 3.14 into 6 into 10, and this should be equal to 3 into x. So the value of x that we obtain, it is, when we solve this value, we will get the answer is 188.4 by 3. This is equal to 62.8 meters. Now how much extra tarpaulin is required? It is 20 centimeter. So when we convert 20 centimeter to meter, it is 20 by 100, that is equal to 0.2 meter. So the total length required is, this is the 62.8 is meter is this value, and extra material required is 0.2 meter. So the total length required is the sum of both these values, that is 62.8 plus 0.2, that is equal to 63 meters. Now next is a corn cob shaped somewhat like a cone has the radius of its broadest end as 2.1 centimeter. So we are saying this corn is out there, and we are considering that it is just like a cone with the base radius 2.1 centimeter, and length is, we are saying it is 20 centimeters. If each 1 centimeter cube of the surface of the cob carries an average of 4 grains, so we are talking about the surface of this surface we are talking about, it contains, if we consider 1 centimeter square of the surface, it contains 4 grains. Then we have to find how many grains would be there on the entire cob. So we know that the grains of the cob are formed on the curved surface area of this cone. So we have to find the curved surface area. So to find the curved surface area, we are saying we have to find the slant height, and the value of this slant height will be square root of 2.1 square plus 20 square, and the answer we will get it is 400 square root of 404.41. So this value we will get it is equal to 20.11 centimeters, and this calculation is shown over here, that the value of L we have calculated, and the answer you will get it is 20.11 centimeters. Now curved surface area of the cone is, we are talking about pi r l. So the value of pi we are taking it is 22 by 7. Radius we have it is 2.1, and the value of L we have it is 20.11 centimeters. So the final answer we have over here, it is 132.73 centimeter square, and this is, we have rounded this value over here up to 2 decimal places. So you can round it up to 1 decimal place also, because this length that is given to us, it is up to 1 decimal place. So it is up to you that how you want to solve this question. Next we are saying that on 1 centimeter cube area, 1 centimeter square area, there are 4 grains. So now the area we have it is 132.73 centimeter. So how many grains will be there? It is 4 into 132.73, and this value comes out to be 530.92, and this is approximately 531 grains would be there. So this is an approximate value that we are getting. This is symbol for approximate value that we are getting over here. Next we are given that a tent is in the form of a right circular cylinder surmounted by a cone. So we are saying this is the right circular cylinder we are saying, and there is a cone on this cylinder. We have a cone over here. Now the diameter of the cylinder is 24 meters. So the radius of the cylinder is 24. So radius of this cone is also 12 meter. The height of the cylindrical portion is 11 meters and height of the cone is 16 meters. So this height over here, the remaining height will be 5 meter. That is 16 minus 11 is equal to 5 meter above the ground. So we have to find the area of the canvas required for the tent. So what we have to do is we have to find the lateral area of this cylindrical portion and lateral area of this cone. So for the cylindrical portion, the formula we know, it is 2 pi r h1. H1 is suppose this height, and for this cone the formula we have, it is pi r l. So for this cone we have to calculate the value of this slant height. So the value of this slant height will be square root of 12 square plus 5 square, and the answer, it is square root of 169, that is equal to 13 meters. So we will substitute the values in these two formulas and we will add these two values. So the final result that we will get is that the curved surface area of the cylinder, when we will calculate, it is 2 pi into r is 12 and height of the cylinder, it is 11, and when you solve this value you will get the answer is 264 meter square. So this is the value we have calculated for the cylinder. Similarly, for the cone, when we will substitute the values in this formula, that is pi rl, we are having it is 22 by 7 into, we are saying radius of this cone is 12 and slant height it is 13. So when you will solve this value, you will get the answer is 156 times pi meter square. So when we add both these values, we are saying this value over here, it is 264 pi meter square, and the area of this tent, it is 156 pi meter square. So when you will add these two values, so you will get it is 264 pi and 156 pi. Both are irrational number, we can add this, pi is there, and when we add these two values, you will get the answer is 420 pi meter square. So 420, pi is now 22 by 7 and these two values gets cancelled, you get it is 60. So the final answer you will get it is 1320 meter square. This is the area of the canvas required to make this tent. Next we are given a right triangle ABC is there with sides 5 centimeter, 13 centimeters. So this side is 5 centimeter, this is 12 centimeter, and this is 13 centimeter, and is revolved around the side of 12 centimeter. I mean this side is fixed and we are revolving it around this side over here. Find the volume of the solid so formed. So when we are revolving it along this side, so it means radius we have, it is 5 centimeter, and the height we have, it is 12 centimeter. So the formula for the volume we have, it is pi 1 by 3 pi r square h. So when we substitute these values, we are getting 1 by 3 pi, radius is 5 square and h is 12 over here, and the final answer we will get, it is 100 pi centimeter square. Next, if triangle ABC is revolved about the side of 5 centimeter, we are saying now this side is fixed and this is revolved in this way. So this 12 is the radius now and this is the height. So we have to find the volume of the solid so formed. So in this case again we will have the formula 1 by 3 pi, then radius over here, it is, now the radius we are talking about, it is 12 centimeter, and height we are talking about, it is 5 centimeter. So the final answer we will get on solving this, it is 240 pi centimeter square, and this is the volume of the second cone, and we have to find the ratio of the volumes of the two cones. So it is V1 by V2 we are talking about. So it is 100 pi over 240 pi. So this is 5. When you cancel these values, simplify this value, you get is pi is cancelled out, this 0 is cancelled out, and we are left with it is 5 by 12. So ratio of both these volumes will be 5 is to 12. Now next we are given that a semicircular sheet of diameter 28 centimeter, means radius is 14 centimeter, is bent to form an open conical cup. So what we have done over here is that this point we are saying O point we have fixed over here, and we have rotated these points over here, and we have converted this to a conical cup. We have converted this figure to a conical cup. So what will happen over here is that this 14 centimeter over here, this will become the slant height over here, and this, if we are talking about the circumference of this AB, that will be basically equal to the circumference, this length ABC over here. Both these lengths will be these two lengths, these will be equal. So if we talk about this length, this is the area of circumference of the semicircle. So circumference of semicircle is pi into r, so that is equal to 22 by 7 into 14, so that is equal to 44 centimeters. So what we get is that this 44 centimeter is now the circumference of this circle. So it is circumference of this circle, it means the radius of this circle will be, we are saying 2 pi r is equal to 44. So we get r is equal to 44 by 2 into 7 by 22. So it is equal to 7 centimeter. So the radius over here we will have it is 7 centimeter. Now let the height of the cone be h. We are saying let the height of the cone is h. Why? We have to calculate the capacity of the cone. Capacity means we have to calculate the volume. So value of h we have to calculate. So to calculate the value of the h, we are saying the value of the h will be square root of 14 square minus 7 square. So that is equal to square root of 196 minus 49. That is equal to square root of 147, and that is equal to 7 root 3. And the value of root 3, if we are using, it is 1.732. It is given over here. The value of root 3 is 1.732. So we are using this value over here, and we get the answer is over here. It is 12.12 centimeters. So this is the value of h that we have obtained, that this height h over here, this is equal to 12.12 centimeters. Now we have to find the volume of this cone, and the formula for the volume we know it is 1 by 3 pi r square h. So it is 1 by 3, pi is 22 by 7, radius of this cone is 7, so it is r square, and height we have obtained it is 12.12. When you will solve these values, you will simplify these terms, you will get the answer is 622.16 centimeter cube. So this is the capacity of the conical cup that will be formed over here. This is the capacity of this conical cup. Now next we are given that 11 persons are to be accommodated in a tent, and each person requires 4 meters square of the space on the ground and 20 meters square of cube of the air to breathe. So the total area required on the ground, it is 4 into 11, that is equal to 44 meters square, and total volume that is required, it is 11 into 20, that is equal to 220 meter cube. So we are saying that we have to find the dimensions of a cone or the height of this tent, for which this base area it is 44 meter cube and volume it is 220 meter cube. So we use the formula over here that the volume is 1 by 3 pi r square h and its value is 220, and the base area we are talking about it is pi r square and its value is 44. So we substitute this value of pi r square over here and we get it is 1 by 3 into 44 into h is equal to 220. So the value of h we will get it is 220 into 3 by 44. So it is 15 meter. So what we get is the height of the tent is 15 meters. H we are saying it is 15 meter. Now next we are given a cube is there, and suppose we are talking about this is the cube we have, this figure we are talking about, and inside this cube there is a cylinder. This is the cylinder we are talking about, that is touching all its side over. This is the cylinder we are talking about, and a cone lies inside the cylinder, and this is the cone that lies in this cylinder. If their heights are same with the same base, find the ratio of their volumes. So we are saying, suppose the edge of the cube it is A, so the volume edge of this cube will be A cube cubic units, and we are saying suppose this is the volume V1. Now if edge of the cube is A, means this side we are talking about this is A, then this base will be A by 2, this height will be A. So if we have to calculate the volume of the cylinder we are talking about, so the volume of this cylinder will be pi r square h, so it is 22 by 7. A by 2 is the radius, so A square into height is A. So when we solve this value we will get it is 11 A cube by 14. This is the value of the cylinder. This thing we are saying this is the value for the cylinder. And third thing we have to calculate is the volume of this cone. So volume of this cone we know it is 1 by 3 pi r square h, it is 1/3 of this value. So 1/3 of this value will become 11 A cube by 42. We are talking about this third value over here, 11 A cube by 40 cube. We are saying this is V3, and this V3 is basically the volume of this cone. Now we have to find the ratio of the volumes, the three volumes. So this thing we have shown in our next slide, that V1 is to V2 is to V3. So V1 is the volume of the cube, then V2 is the volume we are talking about the cylinder, and this is the volume of the cone. And when we solve these values we see that these A cube gets cancelled, and what we are left over here is that the ratio is 42 is to 33 is to 11. We are calculating these ratios. We are saying it is 1 is to 11 by 14 is to 11 by 42. You look at these denominators over here. So this we are multiplying these terms with 42. We get it is 42 is to 11 by 14 into 42. 11 by 42 into 42. These two 42 gets cancelled. This value we get 3. So it is 42 is to 33 is to 11. So we are saying these are the ratio of the three volumes. Next is find the volume of the largest right circular cone that can be cut out of a cube whose edge is 21 centimeters. So edge of the cube is given to be 21 centimeter. We have to find the volume of the largest cone that can be cut from this. So largest cone will be the cone whose this base diameter will touch all these sides and whose height will be equal to the edge length of this cube. So what we get is that this radius of this cone should be 10.5 centimeter and height of this cone should be 20 1 centimeters. Why? Because we have to find the largest cone. If we will reduce this radius, suppose I am saying that some cone is there that is lying over here. Suppose I am talking about some cone is there that lies over here. So clearly we have that the volume of this cone will be less than the volume of this larger cone. So the largest cone we will have, it is the largest radius will be 10.5 and largest height will be 21.1 centimeter. Now we have to find the volume. So it is 1 by 3, pi is 22 by 7, radius it is 21 by 2. So it is 21 by 2 into 21 by 2, and h we have it is 21 centimeter cube. So when we will solve these values, we will get the final answer is 2425.5 centimeter. This is the final answer that we will obtain. That is the volume of the largest right circular cone that can be cut out of a cube whose edge is 21 centimeters.